Welcome back, welcome back. We're looking at bit manipulation problems on LeetCode.io and the LeetCode 150 list. We have just completed the single number problem with the magic of exclusive OR, and now we're going to take on the next one, number of 1 bits. And by the way, in the previous video about single number, I explained to you the bit tables on how you combine bits with AND and OR and XOR. So if you don't know those computer science fundamentals, I recommend to check it out or Google how to do that. It's really, really easy. Right, so LeetCode 191, another easy problem, number of 1 bits. We're given a positive integer n, and we should, write a function that returns the number of set bits in its binary representation, also known as Hamming weight. Interesting. So we're given a number, and it's kind of a decimal number, and we need to count the bits in its bit representation. So the number 11's input, positive int n, write a function in its binary representation. Oh, I see. Okay, so yes. So let's take this example, and here's the table from the last video, how you combine with AND, OR, and XOR. Pause if you want a refresher. Otherwise, let's jump to this. Right. So the key is to understand how you build, how do you convert a number into another base, right? So if you have the number 11 and you divide it by 2, or let's say you take the modulus of with 2, that is going to be 1. That is the modulo. That tells you what is the lower bit, the least significant bit of that number 11 in decimal. Can write 10 here. So this will be 1. And now if you actually divide 11 by 2, that gives you the number 5. Because we do integer division. And now you can do the same thing again. You just take the modulo 2. And that's going to be 1 as well. Now you divide 5 by 2 with integer division, and that's going to be 2, right? And now you take the modulo again with 2. That's going to be 0. Now divide 2 by 2, which gives you 1. You take the modulo again, and that is going to be 1. So now you see that we have, I always keep switching between American and non-American notation for 1. So now you see we have 3 bits of 1. And what this tells us here is that if we write 11 in decimal form, so we have 11 in base 10, so that's in decimal form, is the same as, 1. We have to read from the bottom upwards. 1, 0, 1, 1 in base 2. So that's how you do the conversion between bases. And all we need to do is do exactly what I did here. We take the number, we take the modulo 2 to get the bit, then we divide that number and we iterate until that number reaches the value 0. And then we're done. And we just need to read the result backwards to get the representation. Now for this problem, we just have to count them. We don't actually have to do the conversion. I think the conversion is part of another problem. So all we need to do, we need to have a count variable. And then all we do is while n. So while n is not 0, we're going to say count plus equals n modulo 2. And then we divide n by 2. And when we run this, we'll see that it works, and we can submit it. And we have completed another bit manipulation problem.